It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome. This is day 16 of Advent of Code. I hope you have your cookies ready and your tea ready, because by all accounts, this is going to be a difficult day. Hello David, how is it going?
Oh, is it? I didn't hear about that, but I'm excited for it.
Bring it on. If you look at, and hello Nick here on the chat. So if you look at the historical data, usually the hardest days are on weekends, which stands to reason because people have more time to work on the puzzles on the weekends. And not only that, but not the final weekend, not right by Christmas, because then people will already be traveling and they will want to spend time with family. So, Nick is saying that no, it was very easy.
Yeah,
we can hope.
We've seen Nick's visualizations before. I don't know if we can trust Nick.
Yeah, I am looking forward to this. The bell is ringing. It's time to go. Let's do this. And you are driving today, right?
Okay. Am I? Yes, I am. Okay. Right, let's do it.
All right.
I never remember.
Take it away, David.
All right, I will be reading from your screen, but I'm just going to bring up it on my screen as well, so I have it in both. So, with the beam of light completely focused somewhere, the reindeer leads you deeper still into the lava production facility. At some point, you realize that the steel facility walls have been replaced with cave, and the doorways are just cave, and the floor is cave, and you're pretty sure this is actually just a giant cave. Stands to reason. Finally, as you approach what must be the heart of the mountain, you see a bright light in a cavern up ahead. There, you discover that the beam of light you so carefully focused is emerging from the cavern wall closest to the facility and pouring all of its energy into a contraption on the opposite side. Upon closer inspection, the contraption appears to be flat, two-dimensional squares containing empty space dot, right, mirrors slash and splitters slash and slash. Restarting your computer will start in 54 seconds. No, you won't. Sorry, I had an update scheduled. It was terrible timing. I thought it would be done before, but it will update tonight.
I was almost updating my computer like 1 hour ago, and when he said estimating 45 minutes, I was like, no. I don't think that it would actually take that long, but no.
Yeah, so where was I? The contraption is aligned so that most of the beam bounces around the grid, but each tile on the grid converts some of the beam's light into heat to melt the rock in the cavern. You note the layout of the contraption, your puzzle input. Are we going to be doing some ray tracing at a very primitive level? The beam enters the top left corner from the... Yeah, we're going to need to see the visualization here. So the beam enters in the top left corner from the left and heading to the right. Then its behavior depends on what it encounters as it moves. So I guess dot is empty space, and then let's have a look. Should we try and follow it?
Yeah, I'm following it with my cursor.
Yes. So if the beam encounters one of those, the beam is reflected 90 degrees depending on the angle of the mirror. Okay, 90. So for instance, a rightward moving beam that encounters this slash, which is not the one that you're on, or is it? I can't see because your cursor's on it.
Yeah.
No, it's not. Would continue upward, while a rightward moving beam would continue downward. I can't read the rest of it because you are covering it. So maybe I will continue reading it and you do the visualization, but I'll read it on a different screen.
Well, we all want to read it, so let's keep it there.
No, that's true. Yeah, okay. For instance, a rightward moving beam that encounters this mirror would continue upward, and while a rightward moving beam that encounters this one would continue downward from the mirror's column. If the beam encounters the pointy end of a splitter, then the beam passes through the splitter as if the splitter were empty space. For instance, a rightward moving beam that encounters this would continue in the same direction. If the beam encounters the flat side, the beam splits into two beams going in each of the two directions. Does it lose energy? For instance, a rightward moving beam that encounters this would split into two beams, one that continues upwards and one downwards. Okay. Fine. Beams do not interact with other beams. A tile can have many beams passing through it at the same time. A tile is energized if that tile has at least one beam passing through it. A tile is energized if the tile has at least one beam passing through it, reflecting in it or split in it. I feel like that grammar's off, or am I reading it wrong?
The grammar seems fine. What they're trying to say probably is that, for instance, in this example, the tile is energized here because the beam passes through it. It is energized here because the beam reflects in it, and it's also energized here because the beam splits in it.
Is it? Yeah, it's one of those, right?
Yeah, it's either going to be passing, so it was a dot and then it turned into a beam, or it was one of these splitters or one of these reflectors that was used. So not every splitter will be energized, but the ones in which, for instance, this one, there is a beam passing through it, so it is energized.
Yeah. Okay, cool. Beams are only shown on empty tiles, right? Arrows indicate the direction of the beams. If a tile contains beams moving in multiple directions, the number of distinct directions is shown instead. Okay. Yeah, here is the same diagram, but instead only showing whether a tile is energized or not. Okay. Makes sense. Yep. Ultimately, in this example, there are 46 tiles become energized. The light isn't energizing enough tiles to produce lava to debug the contraption. I almost said contraception. You need to start by I've lost my analyzing the current situation. With the beam starting in the top left, heading right, how many tiles end up being energized? Okay, cool. I think this seems relatively doable for the part one at least.
Part one seems relatively doable. Please start the live share situation.
Yes. Give me one sec.
Mm-hmm. Well, I am feeling energized. Looking forward for a difficult puzzle. Part two is going to be like, now do that 1 billion times.
Yeah. I think it's going to be more like to do with the counting of the number of reflections and like, you know, the number of times that a tile is energized.
So you seem to want to keep track of that in part one, or are we not speculating?
No, I'm not gonna predict anything. No way. But yeah, that's my vague thinking. Okay, so number 16, create a main.py. I'm not on a JavaScript vibe today. And then input, I will put mine in here. And then please paste yours in. Oh, that's pasting the live share. And then I'll paste the input the test input.
Mhm.
Let me find that.
While you're doing that, I'm pasting mine here. No,
Oh,
I
sorry,
stopped.
I'm undoing. Do
Yeah.
yours.
If Xcoli Draw doesn't handle Command Z's at all, Visual Studio Code handles it, but we share an undo stack, and that's no good.
Yeah, what do you think the right behavior is? Because, like, for example, TLDraw just has an undo stack per user, and they don't mix the undo stacks. It's like
I think
my
that
undo
is
stack and your
sensible.
undo.
I think that's sensible. You can think of every action in the text as I added something, I removed it, I removed something, or something like that, and then the undo stack is just removing what you added or adding back where you removed. Probably there are plenty of edge cases to deal with, but in principle, it seems doable.
Yeah, I guess there's the situation. I mean, it's like, I don't know, for a canvas type thing, or even like text like this, which is so multiplayer, like it's so mutable, because, yeah, anyway, let's not get too sidetracked. What's going on there? What are you doing with that zooming?
Because some of the inputs have backslashes, which have a special meaning in programming languages.
Oh. Oh dear. Yeah, that's a good point. Let's have a look at the board and see what we get. Oh, that should be fine actually. Actually, at least I think I know how to handle that. Like that.
Yeah, we have seen this before, right? The regular expressions, I think, used the R.
Yeah.
Yeah, I remember that.
But
But let's make sure we have the R in all inputs.
yeah, let's just print board and see what we get.
Also,
okay, I'm going to make this.
I can see double backslashes already. Do you think that Visual Studio Code is being smart and when we paste it's escaping? No.
Oh, you have to put R here and an R there.
No, it's not. It doesn't seem to be doing that. Yeah, they put 2 backslashes in a row in the input to trick people because most programming languages are going to trip on the backslash. So they have 2 backslashes and that will make things even more confusing.
So they never have a backslash followed by anything else?
No. They have a backslash dot and they have backslash in the real input. And this is pasted correctly. Visual Studio Code is not doing any shenanigans with the pasting. But the syntax highlighting is indicative that the syntax highlighter doesn't know about R, does it?
But it changed when we did R. Look at the difference between this and this. Can you see that?
I can see that.
Yeah, although I'm not really sure.
Maybe
it thinks, it's raw, therefore it must be regex, and it's trying to do regex stuff.
Oh.
Or something.
Really?
But yeah, maybe. I don't know. I guess we could validate with star. Star, and then like a group or something. I don't know, whatever.
It is syntax highlighting a regular expression, it seems. But you have already proved in the terminal that things are fine, right?
Yeah.
Okay.
Yeah. Does that look right?
I haven't read it. So the board is going to be a list, and then the line is going to split, and then each line is turning into a list, and then board string is just joining. Okay, yeah, all of that seems fine.
Yeah, no, I was just verifying the double slashes, but my screen was just in a position which made it hard to do that. So that's now rectified, and we can get on with the problem. What was the problem? It was to work out the ray tracing and then work out how many tiles are energized.
Yes.
When do we stop?
I suppose we stop when the rays go off the board or when they start cycling. So
okay,
there are 2 stop conditions, I suppose.
Okay, my instinct is BFS, my favorite graph
Wait a second.
processing
I
algorithm.
wanna think more about what I just said. Is it even possible for a ray to cycle given these conditions? I feel like
Yeah,
the answer is
I
a
reckon
solid
so.
maybe for me.
It's a solid maybe. Yeah, I could get behind a maybe.
Yeah, it can. It can cycle because you could have a splitter that one of the halves goes into 3 mirrors that point back at the splitter from the other side. And Nick is confirming that yes, it can.
Yeah.
So yeah,
Do you want to do
detect
the
cycles,
example?
detect out of board.
Detect cycles, detect out of board. I mean, that's good enough for me. Do you want to draw the example that you gave? I'm trying to think of one, but if it would hit that, I guess if there's a splitter, yeah, I can see if it hits a splitter and then there's like circles on both sides. I can see that. I can see that. Okay, cool. I'll do that then. I'm gonna do BFS unless you're strongly opposed.
Go ahead.
And
Go ahead.
okay, so I am gonna create a data structure though, just because I want to make you happy. And which is just going to be a cell, just so that I don't get confused with like rows and columns.
You
So I
say
have this.
that as if I didn't use data structures all the time.
No, you didn't. But I'm defining a class, which I don't think you would get behind, would you?
Well, I am all in for classes.
Okay.
Go
No,
object oriented.
maybe I'm being prejudiced. Maybe I'm being prejudiced. It's just one time I suggested that you could use a data class, and you were like, no.
Oh, it was a lot of concepts for me to type, and there is like line 258. What is that doing? And I was like, nope. I'm using a
Yeah, fair
dictionary.
enough. Too much magic. Yeah, fair enough. So, what is it that I want to do? I'm going to do this for sure. Yeah, so I'm going to have my start cell, which will be cells. Oh, cell. Oh no, just sorry, nodes.
I can see you're thinking of this as a graph, and each tile is a node. Okay. And nodes is our work list.
Yes. And then I'm going to call it open list because I like your thinking. And then while
I know you're a fan of BFS, but if you did DFS, then you wouldn't need to have an explicit work list. The call stack could be your work list. I think we did that in the traversal of the string for the day in which we had like question marks that we had to fill in with dots and hashes. We did essentially a depth first search.
What was the question and dots one? I'm not remembering what you're talking about.
Oh, the one that killed me, day 8. The one that you solved with memoization.
Yes, I remember the memoization. Was it day 8? Day 8.
Perhaps don't bother too much because it doesn't really matter. BFS and DFS will both give you the right results.
This day 8 didn't have question marks.
I suppose that DFS would make the problem, would make the code slightly shorter, but who cares? Proceed.
Well, this is DFS anyway because I'm popping the last one rather than popping the first. But I prefer this.
So what have we here? You are getting an open.
Yeah, what do we have here?
Yeah, you're getting one of the cell, and then you have a set of scene. Then you add, then you deconstruct. You check the boundaries of the board.
Okay, now we need to do the actual thing, don't we? Um,
Yeah, I suppose you have to carry not only the cell, but also the direction of the ray that you are tracing. Right?
yeah,
so
which starts,
it's not
yeah,
just cell 00, it's cell 00
yeah,
going to the right.
yeah. So I'm going to have to create another thing for that. If I want to do it this way. Yeah, I'll do that. And then,
Nick was just typing that.
what was he typing?
Probably the fact that you need the direction.
Oh, I see. Direction. Yeah, so that's fine. This is the start cell. And then the start node is that, but to the right. And then I can add my start node here.
Mm-hmm.
And then this has all got to change. While open list, I think it's got to be len open list.
Is an empty list falsy?
Yeah.
Yikes.
No, I don't think it is. No, sorry. Let me verify that. I don't know if that was me or Copilot who made that error. I'm pretty sure it was me, because yeah. So, okay. Oh. Yeah, it's falsy.
It's falsy. I don't love that.
Yeah. Yeah. There you go. Well. YOLO.
I like the way you think.
So we get the node, and then okay, we add it to scene. I'm not decided about this is where I'm going to add it to scene, but that's okay for now. Then we need to create. I'm going to take this. This is all fine. I'm just going to create these. Wait, no, I don't need to create those at all because it depends on the direction.
Yeah, I think that now is a perfect time for you to, number one, since we are doing most of the management here, for instance, lines 284 and even 282 and stuff like that, you could have another set of, what do we call the nodes? Illuminated, bright? We call them something. We have visited the node. A beam of light has visited the node. So we could have a set. Well, you are right. Yeah, that's what scene is. In the end, we just want to print len of scene, right?
Yeah. So we just need to get the next node.
Energize.
So if I guess if the direction is...
No, it's not, because scene is a set of nodes. We are not interested in the length of the set of nodes. We are interested in the length of the set of energized cells. Node being cells plus direction, but we are not interested in the direction part. So no, it's not just the length of scene. We need to have a... Perhaps it would be easier to just have a set of energized cells.
That's fair. Yeah, this just stops me going in loops, I suppose.
Yeah, the scene is necessary for loop detection, and then energize is for the output. One could go over the list or the set of scenes and then deduplicate, but...
Yeah, I'm just wondering whether we need the direction for scene.
We need.
But I guess it can visit the same node more than once.
Yeah, because multiple beams of light may be crossing the same cell. So we need to visit the other direction. And Nick is saying, I use the flags enum to track the angles that were seen as a dictionary. So key equals location, value equals angles seen. What? Can you please
Not sure what.
explain this in some other way? Because I don't think I understand. And I'm going to be nice and mute myself as I eat my cookie.
Enjoy. If it's in bounds, I think if it's in bounds, then we just need to. Do we still want to mark it as seen? I suppose
think so.
But we don't want. We don't want to mark it as. But we don't want to mark it as energized.
If it's not in bounds, correct. I think it's really cute that you can say 0 less than or equal to r less than len, instead of having to say 0 less than equals to r and r less than len.
Oh, this, yeah. This is nice, isn't it?
Mm-hmm.
Yeah. Where was I? Yeah, so we still need to do the direction stuff. So this is the direction out of that cell. And then if it's direction right, and then we need to also map the different characters, right?
Yeah, I think that this is the perfect time to see. Where am I? If I am on a dot, then keep the direction and add the right node. In this case, because the direction is right, I add the right node to the list of nodes, the open list.
Yeah.
And if I am in one of the mirrors, change the direction. And if I am on the splitter, then add 2 items to the open list.
Yes. I'll tell you what I am going to do. I'm going to calculate all of these up front. So I'm going to have right, but I'm also going to have up. Kind of wishing I went with south, east, and west, and whatever, but whatever.
Are you going to say up and right and south?
That would have been really bad. Oh, but now I've messed up these. Let me get rid of that.
And then Nick is saying that instead of a hash set for combined object, like we are doing, a dictionary with the location or the coordinate, what we call the cell, as the key, and then the value for which directions pass through it. Okay, so the amount of entries then is the energized count. 2 hash sets will work just fine though. Right now we don't have to worry about the being.
Sounds like he's telling us about part 2.
Yeah, that's what I'm feeling. So I am not reading the chat anymore. But even with our data structure, it is straightforward to pick up cells that have multiple beams passing through it. Instead of putting a set of energized, we could do something else and store that. Oh, and that's just how he solved part 1. Okay.
We could put it on we could store it on the node as well. We'll see.
Yeah.
So the
energize, instead of the energize being a set, it could be a map or dictionary, as we call it in Python. And then the keys are the nodes, and the keys are the cells, and the values are the number of beams passing through the cell. All right.
Now, let's work out what's going on. So, if the previous node, or the current node, it's going right, and then you hit this, then you need to append both the up and the down, right?
I agree.
And if it's coming from, or if it's coming from the left.
Mm-hmm.
And actually, I don't need any of this, do I really? Oh no, wait. No, I do need this. I do need this. This is all fine. Elif. Does this make sense?
Well, you want an else clause here because you want the bean to pass through.
Oh, thank you for catching that. So, is it just else that I need? Yeah. Well, no, not quite. If no direction.
Yeah, because you want to pass up and down.
Yeah, exactly.
Mm-hmm.
Open list. What? No. Yeah. Yeah. Wait, hold on. If it's coming up, then I need to add up. Wait, hold on. No.
Yeah.
Yes. No. Yes.
Yeah.
Yes.
Yeah.
It's just confusing because I was like, this is up as well. Okay.
Yeah, it wants to go up.
Yeah. Okay, it's useful to have the characters there when you're looking. So then, for this one, yeah, I'm coming from up, then it splits, or down. Whereas if it's coming from the left, then we add the left. Cool. Thank you, Copilot. Then these ones. Does that look right? What happens if it's coming?
If it's going up, go right. If it's going right, then go up. If it's going down, go left. And if it's going left, go down. It seems right to me.
Yeah.
For you all watching at home. My face was on top of it.
I don't need to do that. Does that not work? Why doesn't that work?
When you're writing your strings, you use single quotes. Is this a Python style, or do you do that because you're British?
I do that because I'm British, and it's a hangover from the empire that we had. I don't know why.
I liked when you had the R here. Can we have that?
Yeah, me too, but it didn't. Well, like the syntax highlighter didn't like it.
The same with the flag for JavaScript regular expressions with Unicode awareness, the V flag. It also messed up the syntax highlighter.
Yeah, I'm not gonna fight it. I want my syntax highlighting to work.
Yeah.
Okay, is this right? So up, left, left, up. Yeah. Down, right, and then to the right, down. Yeah. Seems pretty good. Are there any other characters that I didn't check?
That is it.
Cool. And then, is this everything? Maybe. Am I? Yeah, I'm adding the. Is this correct? The direction of the new thing.
Let's see. We are storing row and column.
Yeah.
Row goes to the top. Right goes to the. Yeah. We have done enough of those that now this is second nature.
Yeah. Okay, should we just run it for the small input and see how see it crash your terminal?
Yeah, we could also print something in the end. How about we print the
Yeah.
length of the energized set?
Sure thing.
And I would be very happy if I see 46.
Oh, why can't I run this? Okay, cell is not defined. Line here. That makes
Indeed.
sense.
Yeah, it's node.cell.
Index out of range. Alrighty. Oh, well. That will make sense. Okay, energy set. Empty set. But, well, first of all, I didn't print the length, but it's weird that it's not printing it. Yeah, it's 0. That doesn't make sense. So it's exiting on the first. If the row column is not in the bounds, then continue. That makes sense.
Yeah.
Let's print the nodes as they come. No nodes. One node. The top one, and it's going direction right. And then nothing more. What is the first? Yeah, the first one is a dot, which makes sense. So it should go into the dot one, and then it should add one. But I guess the open list. Were we expecting it to go here?
Yeah.
Doesn't go there. What's the chart? It doesn't get there. Wait, is my inbounds not working?
Do you have extra new lines above the board and below the board? Did you clean up the new lines?
I didn't really clean them up, no. No, let's do that. But I don't... Okay, if...
I say that because when looking at the terminal, I see extra lines above and below, and that's eerie because then we could have a space as the char in line 3.
Yeah, I get that. That was it. Brilliant. 46.
All right, everyone. Can you run my
Is that
example?
the answer?
Yeah.
Oh,
yes.
yeah.
Yeah.
Oh, that's
good job.
nice.
Good job.
Okay,
Good
cool.
job.
Good job, us. Oh, why am I printing still? But 7884, is that the right answer?
That's the right answer.
For you.
Woohoo!
Woohoo! All right, I'm going to, for the first time, well, not maybe the first time, but I'm going to get my star in real time as well.
Okay. Do you have your 31 stars?
All of them so far, yeah.
Awesome.
Yeah.
Thanks, Nick.
Okay. Okay, so now I can uncomment yours and uncomment the example and read part 2.
Let's go.
As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There, a collection of buttons lets you align the contraption so that the beam enters from any edge tile, and heading away from the edge.
The other day I was trying to say incense, and I said incest. So yours is not so bad.
Yeah, there's worse. There's worse, definitely. So you can choose either of 2 directions for the beam if it starts on a... What? There are a collection of buttons that lets you align the contraptions so that the beam enters from any edge tile and heading away from that edge. You can choose either of 2 directions for the beam if it starts on a corner. For instance, if the beam starts on the bottom right, yeah, okay, it can be left or upward. So the beam could start on any tile in the top row heading downward, or any tile in the bottom row heading upward. Any tile in the leftmost column heading right, or in the rightmost heading left. To produce lava, you need to find the configuration that energizes as many tiles as possible. Huh. Memoization! In the above example, this can be achieved by starting the beam in the fourth tile from the left in the top row. Using this configuration, 51 tiles are energized. Find the initial beam configurations that energize the largest number of tiles. How many tiles are energized? Blah, blah, blah.
Wait a second, memoization, you say? I get the feeling that we can just brute force this. Maybe I'm wrong.
Yeah,
but
I was also thinking. I was also thinking brute force as well. To be fair.
Yeah, because we have here, I want to say like 100 columns and maybe 200 lines. That amounts to less than 1,000. Let's just go for brute force.
But loops, I suppose.
Yeah, I suppose the thing that we want to do is, in our code here, we will want to wrap this whole block with a loop. And
yeah. I'm just sorry, just before we get into this, I just got a bit confused by what it said at the end of the description. It said, using this configuration, in the above example, this can be derived by starting the beam in the fourth tile from the left in the top row. Okay, so it's saying that 51 tiles are energized. This is the best configuration to have. Okay, sorry. Yeah, I just wasn't sure what it was saying. Okay, cool. Yeah, put this block in a function and then try brute force. Is that the conclusion?
Mm-hmm. Yeah, I wouldn't even put it in a function. I would just put it in a for loop.
Of course you would. That's classic.
Because all we need is a different start of the open list.
You're right.
We just need
a different direction.
Yeah, the open list includes the cell and the direction, so we would just need to have a loop of cells and directions.
Yes. Do we want to think about not brute forcing it, or should we just try brute forcing it and then see if we have to not brute force it?
That's a good question. Well,
I want to spend 1 minute discussing how we would do this if we didn't brute force it first, because it might be just as simple to implement.
What about this structure we can reuse? Well, because of the way that the problem is defined, I am sure that we will never see, for instance, I start here, so I can only go to the left. I can guarantee that I will never see any other of these columns, any other of these lines here on the last column going to the left, because it would need to come from outside the board, and that's not possible. So, given that that's the case, there is not a lot that memoization would buy us, I don't think. Unless there are like, I guess memoization would help us because as soon as we split the beam, it doesn't matter if it's coming from the left or from the right. So some work that, for instance, would have been done by this splitter could be reused if we could reach it from the left and we could memoize that work. But
yeah, I feel like if you arrive at any node at the same direction, you can memoize the entire subtree underneath it.
Yeah. Other than that, I don't really see the opportunity for making anything too smart about this, because you have to carry through. Well, maybe instead of in our loop, we go step by step, dot by dot, and perhaps that is going to be a bit more work because we are adding to a list and then popping from the list. So we could just try and have a loop that traverses all the dots up until it reaches the end of the board or one of the other characters. But I think that is a negligible thing. I don't think it would speed things up too much.
I was thinking we could, if we did all of the paths in parallel, but then I don't think that would help us much because we need to explore all of them to work out when the last one finishes, because we're looking for the maximum, not the minimum. If it was the minimum, then we could exit as soon as the first one exited. and then we could use that strategy. But
one thing that we can do to make this faster, possibly, is represent this. It's kind of following up on my previous idea of jumping through all the dots in one go. We could represent this as a sparse map because most of what I see is dots. Right. Sparse matrix, I should say. We could represent this as a sparse matrix, and we could even be smarter and connect the dots. So for instance, we know by construction that if you arrive here from the left, you are going to go up. So we could embed this in the representation that we use so that this node becomes connected to that node. If you're coming to it from the right, you're going to immediately jump there and immediately split instead of having to traverse the board all the way. And
that is, yeah, go on.
No, I guess that's the idea. I don't like it, but it's one idea.
Yeah. It's definitely very clever, but it would cause me a lot of headaches to do the counting afterwards. So with all that said, we have some ideas. If brute force doesn't work, let's do brute force.
Yeah, I mean, worst case scenario, I guess we could... No, this map that I just described, this map that I just explained out loud, it kind of amounts to the table that we are going to build up with memoization. I suppose.
Okay.
Fairly sure. I'm fairly sure of this.
Let's try brute force first.
Yes. And Nick is saying, I started out with a sparse map from the start, but the problem is so simple that nothing special is needed, in my humble opinion. Some people managed to write code that ran for 20 minutes. I don't understand how. Just testing all the paths is fast. Well, we are up for the challenge. We can take 25.
Yeah. So right now we just have the start cell and this is the start direction.
Before we continue modifying the code, can we create a copy?
Of course. Good time to do that.
Oh, my camera is frozen.
Is it?
Yes, my camera is frozen. You can continue. I'm going to be restarting my camera here.
All right. So we need to get all the edge cells. So for R in that, So I'm going to do the columns, and then I'll do the rows, and then I'll be good. Maybe I'll do the first row separately, but so I'll add all of those, and then I will add the and then I'll finally add those. Does that make sense to you?
You ask if that makes sense to me. Well, first of all, I'm a bit blurry now, but the camera is back. And second of all, I was not looking at the code, but I can look at it now. So let's see. You have the start cell, the start direction up top. I suppose that this is something that you're going to change later. Then the edge cells.
I noticed some issues. So this is not right, but this should be right. This is the first row. And then I want to add all of the ones in the first column, and then all of the ones in the last column. Then it's okay.
Yeah.
and then finally the last row. So now I've got my edge cells. I don't know, maybe edge is a bit confusing with nodes, so I'll call them border cells. Or exterior.
You have
border.
your edge cells. While you're constructing the edge cells, how about you already add the directions? And then create nodes.
Because... Yeah, go on then. Yeah, so for the cell... So for this one, since we are coming from the left of the board, they'll be going right.
I don't like the parentheses in that line.
Nobody does. Okay, cool. Good spot.
And Nick is asking about my webcam situation here. No, I am using a Cam Link and I'm using a Canon camera, which always worked. But then I updated to macOS Sonoma and now it's not working anymore. And I don't really know why, but it's freezing. The Canon software is always crashing. Did you ever have, you're saying that you have a Logitech Brio. Before I got this camera, I considered getting it. And I heard that the Logitech software, I think it's called Logitune or something like that, was not the best. You always forgot your settings and you had to click around. Is it better now? This has been like probably 2020. So is it better now?
Are you asking me?
No, I'm asking Nick.
Okay.
Meanwhile, you're hard at work. Your border cells from the top are going down, from the right are going
yeah.
left are going right, from the right are going left, and Wait,
Top
why?
Left corner.
Why?
What's that? Sorry.
Why this line 287?
So the corner cells can go either down or like they can go in two directions. You can choose, right?
Yeah, but why do you need these special cases? Line 287 is covered by lines 286 and 293 in combination.
I've got rid of those cases. I was like specifically getting rid of them, but actually I need them.
It's funny that you were getting rid of them and writing lines for special cases.
Yeah. Whoops. Okay.
Now only missing line 291.
Exactly. Which I'm sure Copilot can do for us. Come on. Yeah, that looks right. It's the last row and it's every column and they're all going up. Sure.
Yeah.
Looks good to me. Okay, great. So now all we need to do...
And you're calling it border cells, but it's more like nodes because they contain the direction.
Oh yeah, they are. They are now, yeah.
I would call them vectors. Because they're a position and a direction.
Yeah.
No, don't change the name though. Continue.
Yeah, we're gonna have to rename everything for that.
And I want to follow up with Nick on the software situation. So you're using the basic driver, and do you control focus and brightness and white balance and all of that just using the basic drivers? Because that is pretty cool.
Your audio is clipping a bit, by the way. It's like choppy a little bit. I don't know if that's my end though.
Yeesh.
Very little. It's pretty bearable.
Oh, well. It's interesting.
Um,
It seems like I can either stream from my laptop and then the stream is laggy and the camera quality isn't so good and the microphone quality isn't so good, or I can stream with the complicated setup, 2 computers, and then I have other issues. But the perfect stream seems unattainable.
Yeah, one sec.
Okay. And Nick is saying like everything is in auto. Interesting. Perhaps I should do that. Yeah, it's a hassle indeed.
So we go through each of those, and then we do all this.
Well, start cell and start direction doesn't seem right. You're overriding start node.
Oh yeah. Max energized.
Yeah. Yeah, the problem is, I'm talking to Nick now, the problem isn't even the computer this time, it's the operating system versus the custom software that needs to run in all this. And I don't even know if it is now macOS fighting CamLink or macOS fighting Canon, because I have not only the CamLink to get the HDMI feed from the camera, but I also connect the camera to the computer so that it can set things like exposure from the computer without having to like reach to the camera, which when it worked, it was pretty cool. Watch one of my streams from from last year. It worked very well, but then with updates, it's not working so well. What have we here, David?
So we got the right answer for the example, and now we are chugging away. We have an intermediary best max energized. We might have just got lucky, but who knows?
And
I guess I don't know how many we've gone through, to be fair, but that might be the answer. But we haven't finished the program yet. Do you want to try it?
Is this my input?
Yeah, this is yours.
Nope.
No. Too low. Okay.
Yeah, well, too low is good. It means that it just needs to keep going.
Yeah. I think we might be one of those programs that Nick laughs at because it takes 20 minutes. I've got 8158. It's annoying that I'm not printing out all of the indexes of the nodes. I don't know how many we've done.
Is there any case here where we should be using a simple for loop and we aren't?
I
don't think so. We are never instantiating.
No, but maybe we don't need to, like, it would be better if we didn't compare strings or something.
Well, the border nodes is something that we are creating from the beginning, and we could just use a simple for loop there. But I don't think that the border nodes are killing us.
No, I don't think so.
Oh, I have a new Max. I'm gonna try it.
Yeah.
That's the right answer. Good job. Hey. Another one in the bank, everyone.
A star is a star is a star is a star.
I am happy.
Okay, brilliant.
I am ready to call this a day. Maybe we can go to Reddit and read some of the inputs from there, because, I mean, we did this in record time.
All right, sure.
And David is, not David, Nick is saying, I did the bounce checking before adding it to the queue. Isn't that what we do?
What does he mean by that?
We are doing that.
No, we add it to the queue like here, right?
Yeah, but we did the bounce checking above.
No, but this is here where...
I see. Doing the bounce checks
take
here.
it off and then...
Okay. Okay. Yeah, this really was an easy problem. I'm surprised. Everyone in the subreddit was like, this is the calm before the storm. And I don't see a storm.
Really?
Saturday was easy. Now, I cannot speak for Sunday.
Yeah.
But Saturday was very straightforward. Easier than day 8.
I think.
Jeez, I have nightmares about day 8. Do you have your answer yet?
No, I'm still waiting. I think mine is not at the beginning.
This is cute.
Oh, that's really cool from the day before.
Yeah, that was my computer on day 8. All right, let's see. Oh, they have animations for the beams. Oh, cute.
Oh, wow.
So the beams were really going everywhere. No wonder it takes a little bit of time.
Yeah. This is cool though. Go up. How is this effect done? I'm curious about that one.
Oh,
it said spoiler, so I didn't want to click on it.
It said spoiler?
But yeah, so.
Oh, let's look at the tree then. I want to see the effect. Haha. That's cute.
Well, it's not ASCII art, is it?
I suppose it's just drawing lines with something like SVG and using not a drop shadow. Yeah, I guess a colored drop shadow would do. It's not even using SVG, it's just using spans and a text shadow. So I was not too far off. Let me do this so you all can see. Yep, text shadow, a colored text shadow.
So then what's it animating?
Well, it's animating the opacity and the X position or the Y position.
I don't see the animation though in the code.
I suppose it's done with JavaScript.
But then you'd see the value changing, no? When you're not seeing the value change. Would you see a value changing here? I suppose. Well, yeah, I think we would see. But it must be JavaScript because there is nothing CSS here. Yeah, I'm just gonna say that it is JavaScript somehow and count myself happy. Let's see if people agree. Hey, I got my gold star.
Yay! All right, let's go to day 16, look at some solutions. Starting from the best. Python. Today was another good opportunity to use match statements. That's just going to simplify our nested ifs. And complex numbers. Interesting. They are using probably the imaginary part to keep the direction. Yeah, and then to change the direction means to to negate the number, I guess.
Sorry, say that again. I wasn't concentrating fully. What are they doing?
They are using match statements to do the nested ifs that we did. And they are using complex numbers. I suppose they're using the complex number as a way of keeping the direction. Oh, no. They're using complex numbers to store the coordinates.
Okay.
Yeah.
That's a really neat trick, actually. In a way. I guess couldn't you do that? Storing the coordinates just in a long integer? Why does it need to be complex?
Well, let's see. It needs to be, well,
Is it
it is wildly convenient to use complex numbers because complex numbers are just a coordinate into a Cartesian plane, right? The real part being the x-axis and the imaginary part being the y-axis. So that is that is that. But why not use an integer? Well, as long as you are willing to do something like a Hilbert path, a Hilbert curve, then you could store it as an integer. Do you know about Hilbert curves?
No. Go on.
All right, yeah. So you could also just index this as a single integer if instead of thinking of this as a board, you can think of this as a one-dimensional string separated by new lines, and then you could just, instead of going down, you add however many characters there are here, right? And then you went down by one line. We saw that in the regular expression for one of the first days. But
well, no, I was thinking just use an integer, but because the board size is not that big, you could just, have the first 250 numbers for the x, and then the second 250 for the y, and then you could always destructure it that way.
You could. Then you're essentially bit masking, right? You could do that.
Yeah.
But the nice thing about complex numbers is that you get arithmetic for free.
That is nice.
Yeah, so for instance, to change the direction is just to negate the number. Whoops. I clicked on the wrong thing here.
It's cool.
That's cute. A neat trick for future days. Not that I have access to complex numbers in JavaScript, but using Math.js, I do.
Yeah. Well, probably it's pretty trivial in Python. I have not used complex numbers in Python, though.
Had a pretty good time with this one. Just a straightforward search. Brute forced every position. It finished in a couple seconds.
Probably using a faster language. Oh, no.
Yeah, that's Python. They're using some maps and stuff.
Wait, they've only got scene.add. They don't have... How are they doing energized? Tile...
Well...
energize... Oh, there you go. They build up energized in the end from scene.
Yeah, they're just pulling out the coordinates and removing the directions and creating a new set.
Got it.
Is this syntax for creating a set?
Yes.
So, yeah, very familiar.
Indeed. I don't use DQ, though.
Yeah.
Why do they use DQ? Maybe that's the fast bit, because there's nothing about so there's this Q, and then whether they reference Q, they only do pop. I think that it must be faster. That's the only reason.
Are we using append as well? Yeah.
Yeah. But the only reason that we would a list covers all the things, DQ just must be faster. It's the only reason that I can think.
And Nick is saying just CSS animations with offsets. I didn't see any CSS animations. That's for the little effect here, but
confirmed. DQ is just faster pens and pops.
I suppose it is not doing the whole list shift. That's cool. Sequence SQL N is BFS DQ. Okay.
This is DFS. Yeah, this is DFS. Yeah.
Graph traversal, brute force, fun problem. You have to memorize on the position and direction. If you don't memorize, you get stuck in loops. Well, I wouldn't really call it memorization. It's just checking that you are not going in a loop.
Yeah. I'm very glad to have finally got a very easy problem.
A rough day for me. I had a subtle bug in part 1 that took forever to fix. I suppose these are people who are trying to go for... Yes, this person is trying to go for the board. So that's why they thought it was a rough day. Deep copy, GCD. What? Are we talking about the same problem?
I guess they're just ready for any problem.
No, they must be using it. Come on.
No.
No, they're not. They're not. They're not. Yeah, all of this looks very familiar.
Using all caps for variables. It's kind of nice for like this kind of code golfing, like, or for speed kind of thing. Because it makes your typing less and you can differentiate things quicker and stuff. But I don't have a caps lock key because I use it for control, so that would be very slow for me. But it's fine, I have Copilot.
And why are they using NumPy?
Then
no, that's a joke. No. That's a joke.
Okay. Just making sure.
Come on, that's not what I'm here for. I want to see the crazy.
Vim.
Okay. Let's see if the Vim person. Nope.
I mean, the visualization ones are pretty cool.
Yeah. What? Parses the string into a dictionary of... Okay.
What did you say it was called when you when it's like when you make everything 1D in a 2D map?
Oh yeah, so there is this way. In this case here, we have a finite board, right? So we could just say that we want to find any... If we want to linearize this board, we can just go to the end of the line and then wrap back. So you could traverse the board like my cursor is doing, left to right, top down, like we read. But what if, in the general case, you want to traverse the board with infinite bounds? So it's an unbounded board, an infinite area, but you want to have some linearization that is guaranteed to visit every point in the board. Well, you cannot simply go left to right, top down, because when are you going to wrap the back down? And if you don't wrap back down, you're not going to visit line 2. So what do you do?
Just do it in chunks?
Well, there are several ways of doing this. You could even, for instance, go in a spiral. But there is the problem with the spiral is that you tend to visit neighbor nodes very far apart in time.
How do you do a spiral?
Oh, you'd start here in the middle, and then you go up, and then to the right, and then to the bottom, and then go around, like my cursor is roughly doing. And you're guaranteed with this, you're guaranteed to visit every point in the plane. But the problem with a spiral is that you're going to see neighboring nodes very far apart in time, which for some problems is not ideal.
Yeah.
So there is this rule.
I can see that like defeating the point of doing the 1D-ness.
Yeah. And for instance, if you care about cache, if you care about caching registers on the CPU and stuff like that, you want to have the neighboring nodes visited roughly nearly in time. And then there is this thing called a Hilbert curve that will visit every dot or every point in a plane. And it's a fractal. It's super cool. And if you had a board that is not discrete, because this board is discrete, right? We have dots and we jump from one dot to the next. But if you had a continuous board that is a continuous space, the Hilbert curve is still guaranteed to visit every point. And that is crazy if you think about it.
I don't understand how it does that.
How it visits every point?
Well, yeah, I'm looking at it now.
Oh, you're looking at the Hilbert curve.
Yeah, maybe you should bring it up, yeah.
Let's go there.
So there's a GIF in the top right. I don't know if that helps. Or maybe the image is more useful. So what does this mean? What am I looking at?
Well, you're looking at a fractal, and it starts with this, and then each of the lines is going to turn into one of these shapes.
Mm-hmm.
And then each of the blue lines is going to turn into one of these shapes again. So we are kind of
each of
stamping.
the nodes. Each of the nodes. Because like in the first image, there are 4 nodes. Is that right? There's 1, 2, 3, 4. And so you visited all 4. And then if you want more nodes, then you need to, for every node, you create 4 nodes. So 1, 2, 3, 4. Is that right?
Yeah. And let's look at the production rules here.
But do you not need to know how many nodes you have up front? I'm not seeing how it expands from like 1 to like a board of 4 to a board of 8. Like, do you just need to remap everything?
Yeah, just now you're looking at the blue line, rinse and repeat. So each one of these U curves is going to get stamped with one of these blue shapes.
Mm-hmm.
And if you keep doing that, so this is the third order, the gray one. If you do now the same exercise for each of these U turns here, you stamp another one of those, you're going to go, I guess, deeper and deeper into the board. And if you keep doing that to the limit, you're going to visit every point in the plane. So in a way, you have a line, which is crazy. Think about a mathematical line. It has no thickness to it. And yet a line can visit every point in a 2D plane. Isn't that crazy? You can fill in space with a thing that takes no space at all. And I like I just think that this is amusing. And I implemented code that does this graph, like we see here. And then I changed these production rules so that you would not get maybe one of these. They would start crisscrossing. And as far as I understand, crisscrossing the lines still preserves the property of it filling the plane. And I used that for the logo in CourseLore. This is what you see here. And in fact, this that you see here is probably order 2 or 3. But the code, this SVG is created with code that every time that you boot CourseLore, it recomputes the SVG, and you can have higher order Hilbert curves here.
That's very cool. Do you not have to do a disclaimer that you're sponsored by CourseLore?
True. It is my day job. And I wanted this to be the logo of CourseLore because it's a communication platform for students and educators. And conversations are usually called threads. And the idea was that if you keep iterating on these threads over and over, you will fill in the plane of knowledge. And conversations don't always go neatly organized. Sometimes they crisscross like this. So there is a whole story to why the logo is what it is.
Yeah, that's very cool.
And I have a video on my channel of me implementing this, in fact. It's very cool.
It rings a bell. I don't remember Hilbert curves, but yeah, that's very cool.
Yeah. This is nice. I like this kind of visualization, which you cannot see, but now you can see, but it's kind of small.
It's very satisfying.
It is very satisfying. And this is showing how you could visit the board and visit every node in the board. The neighboring nodes are visited relatively...
you said the issue with the spiral thing was the spatial locality of it, but does this really improve that?
Well, if you load one of these squares in the CPU cache, for instance, you're going to be visiting all of them, while if you did the spiral, you would load one of these squares, then the next square, and so on.
Yeah, especially as you get further and further out. In the beginning, it's okay, but obviously it doesn't last for long. Yeah, that makes a lot of sense. Yeah.
Yeah. All right.
Okay.
Nick is saying my intro song for the streams is an earworm. Found myself singing this morning. I love to hear that. Thanks for saying it. All right. So I think we are done here. And it has only been 1 hour and 20 minutes, and we had time to go on tangents and look at other people's answers. We are on fire. You are on fire, David. You are on fire.
You. No, you.
Well, tomorrow
right.
we'll see if I am on fire or not, because I'm expecting a difficult one. It's coming. I see it coming.
I feel it. I feel it. Yeah. All right. I look forward to it, Leandro.
Yeah.
See you tomorrow.
Do you want?
What time do you want to do?
That's what I was gonna ask. I think I would prefer in the evening because then I can enjoy a sunny day. But if you can only make it during the day, I can do that.
Sure. You go for it.
All right.
Enjoy.
So does it mean 10 p.m. or can you do a bit earlier than that?
Sorry, I didn't hear that. Did you say a little bit earlier? Yeah, I'm easy either way. Ideally, well, actually, at 10 p.m. would be better. Yeah.
Okay. So tomorrow, Sunday, 10 p.m., day 17 of Advent of Code. I'll see you there. Have a good one, everyone.
See you there. Bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.